Okay, in this video, we're going to learn how to graph your quadratic functions, okay? So over here, I have my quadratic function, y equals x squared plus 6x plus 5. You know it's a quadratic equation because it's a second degree equation. As I set up my calculator, I am going to do second mem, which is above your plus sign, 712. That just resets my calculator, so I'm ready to go. Right? In order to graph this, I just need to get my xy pairs. Remember, y and f of x are the same thing. You could plug in each x value to get those corresponding y values, but that's where the graphing calculator is super cool. You can just type it in. So I have my y equals. I'm going to type in my x squared. As I'm doing this on my calculator, you should be doing it on yours as well, just to be sure that you know how to do it, right? I could hit graph and I can see my parabola. If I want to put it onto my graph paper, this isn't really the greatest feature. Instead, I'd rather look at that table. So I'm going to do second graph to activate the table feature. Now notice this table that they're giving me is requesting this domain from -6 to 0. So I'm going to actually shift up on my table so that I can get the values that it is that they're asking me for. And I'm going to write down my range for this given domain. So in other words, I'm going to take down the y values for the x values. Okay, so I'm just going to record these. Okay. And again, you should do the same. Now, as I'm writing these down, I'm actually just going to plot them as well, just to kind of talk as I plot. And again, you should do the same. And you always want to stay smarter than your calculator. So as I'm graphing these, I want to make sure I'm realizing that they should form a parabola. So you almost start to anticipate the shape it's going to make. The nice thing is that it is symmetrical. So when I come down here and I'm graphing the point -3, -4 right now, it's easier to graph the other side, -2, -3. It's symmetrical. So -1, 0, it is symmetrical. So these points are lining up. And 0, 5, it is symmetrical. So I do have this parabola forming. Another thing you want to notice that's happening because of that symmetry is you have this -3, -3, 0, 0, 5, 5. It's like a rainbow effect that's going to happen. Now, we found this rainbow because we were given these x values specifically to graph this parabola for. Down here, I'm going to talk about an axis of symmetry formula that will eventually help you figure out how to find those specific numbers, right? But in the meantime, I am going to graph this. Now, normally what I would say to you is when you are graphing a parabola, you want to make sure that you are graphing all the points that fit on your graph. So whatever points from your table of values fit on the graph sheet that you have, you want to graph all of those points. Don't wimp out and just graph a couple of them. Graph all of them. Make sure you're putting in your arrows. I wish my graph was a little bit smoother, like this parabola shape. It's just a little difficult on the smartboard. All right. All right, some connections to make. So here comes the cool part. So if I were to take this parabola, or sorry, this quadratic, and I were to factor it, where I want to write it in factored form, okay, I'm going to come over here and I'm doing my AM factoring. It's a trinomial where I'm going to keep my y equals because that part isn't changing. So it's my y equals, and then I'm just going to factor this. So what multiplies to give me 5 and is going to add to give me 6, I'm going to use those factors of 5 and 1. So I'm going to write x plus 5 and x plus 1. Okay, then this is going on to ask me the roots. Now, you guys learned to find your roots from a picture in the past, and you found them by where the graph is crossing your x-axis, your x-intercepts. You can also find your x-intercepts where your y values are 0 in your table. So I can see that my roots, or which is the word that they're using here, the roots are -5 and -1 because that's where my y values are 0. I can also see that it's crossing the x-axis at the -1 and the -5. So those are definite ways that you can find your roots, which is connected back to when you solve your quadratic equation. If I were to go through the process of solving my quadratic equation, that was another way to find your roots. Remember, when you're solving, you would set your y value equal to 0 to solve, and then you would just do your x plus 5 is equal to 0 and your x plus 1. That was that zero product property we were using. And when you solve this mini equation, you would get that one of your roots is -5. And when you solve this quadratic equation, you get that your other root is equal to -1. So your roots are -5 and -1, found from solving the quadratic, or looking for your x-intercepts, or finding the zeros for your y values and taking those corresponding x values. And that's why these roots take on the word solution, zeros. So those are multiple, different kind of language that you're going to hear. Your vertex is the turning point of the parabola. So the vertex is right here. It is your turning point. And again, I can find it on the table because it happens to be in the middle. See this rainbow effect that we talked about? Your vertex happens to be smack in the middle of your rainbow, which is, again, the coordinate of that point, which is -3, -4. And remember, it's a vertex. It is a coordinate. You want to write your coordinates inside a set of parentheses. That's an XY coordinate. All right, notice up here, my roots, another way you could have written your roots is inside your squiggly brackets if you wanted to put them in set notation. But you cannot write your roots in parentheses at the same time that you must write your vertex inside a set of parentheses, because it's a coordinate on the graph, right? Another question that they're going to ask you about a parabola is this idea of, does it have a minimum or does it have a maximum? So looking at our parabola, it has a minimum because this turning point is the lowest point of the graph. So it's really your turning point that's going to tell you. So when you have a minimum, you have what we call an upward facing parabola, and that makes the turning point the minimum point. You can also graph a parabola that is downward facing, and in that case, this turning point is a maximum point. So this is a situation where I would say it has a maximum, but for the picture that we drew, it actually has what we call a minimum. Okay, so it's a min. Those are all your points for your quadratic, all right? Let's talk about this axis of symmetry, and then we're just going to go through everything all over again, right? So there's an axis of symmetry formula. It's x equals -b over 2a, which actually is a part of your quadratic formula. It's the -b that starts and then the 2a on the bottom. So it'll help you memorize it. So if we were to look at this formula up here, the b value is +6. So -b would be -6, and it's 2 times the a value, which would have been 1. And you would get -6 divided by 2, which means you would get -3. Now, you have to realize it's not just that the axis of symmetry is -3, it's that the axis of symmetry is x equals -3, right? Now, two things about your axis of symmetry. Number one, it is what gets placed in the middle of your table of values so that you get that rainbow effect around it. See how the -3 is right here? Once you place that x equals -3 in the center of your table of values and you just go up and down from there, you will find that rainbow effect in your table. So that's the first role that it plays. The other role that it plays is that it's actually giving you the equation of the line to which this parabola is symmetrical. Remember, we talked about your vernox, your vertical lines have x equal equations. So the equation of this line is x equals -3. So this is the actual equation to the line of symmetry for the parabola. And that's why it's called the axis of symmetry formula. A lot to take in, but we're going to kind of come down here and we're going to start all over again. We're going to do everything we just talked about. So number one, this first equation is not in y equals form, so we're going to have to get it into y equals form. So I'm going to get it. I'm going to move my 3 over, and now my new equation is y equals -x squared plus 2x plus 3. And again, you should be kind of moving along with me as we go. See this negative x squared? That's going to create this minimum situation where now my parabola is going to be downward facing. I'm anticipating it happening. And when I come over to my calculator and I type this in, I'm going to hit clear. I'm going to do my negative x squared. It's going to be plus 2x plus 3. And again, if I hit graph, I say, oh, yep, that makes sense to me. I have a downward facing because I had this negative x squared as opposed to a positive x squared. All right. So now if I were going to record my values. Now, again, let's just play around with the axis of symmetry. I'm going to work in my x equals, sorry about that, x equals negative b over 2a. I'm going to use my y equals equation. So negative b, negative 2. Over 2 times negative 1, which is just that negative 2 over negative 2. So now I have 1. Remember, my axis of symmetry is not 1. My axis of symmetry is x equals 1. So that means what I would do is I would put a 1 in the middle of my table and I would go up, which I think it decreases as we go up. So if once I look at my calculator, which again, you could just easily fish for this on your calculator, but stay smarter than your calculator. It's a better idea, right? So now I'm going to go to second table. Let's see if this worked. I'm going to scroll, right? And so I'm going to put my cursor on the negative 1. And sorry, what did I say? It was positive 1. Okay, good. Let's go down to positive 1. And now I can see 3, 3, 0, 0, negative 5, negative 5. So sometimes I refer to your axis of symmetry as like the GPS of your parabola. It helps you find it. So I'm going to put in these values. Now, as I put in these values, I'm also looking at the one value that was above the negative 5, which was negative 12. And negative 12 would not fit on my graph. So I'm not going to graph the point negative 3, negative 12. It's just not going to fit. So now what I'm going to do is I'm going to graph my points. I'm going to try to do this in a timely fashion. Again, I want you to do the same and just be careful graphing. And I'm also anticipating this downward facing parabola as I'm graphing it. And then the fact that it becomes symmetrical, like once I did half of it, I'm so happy because the other half of the parabola is so much easier. I'm going to come in, I'm going to graph my line. And I'm not going to forget my arrows, right? So I'm going to come in. Sorry that I can't. Now you want this to be smooth. I don't want it to be, remember, I kind of don't love that this is a little pointy. It's a little bit harder when I'm on my smartboard here. So be a little bit forgiving, but you want this nice smooth parabola and try to hit all of your lines. All right. So over here, what is my axis of symmetry? Okay. We did that. My axis. Now again, if you write 1, you're getting it wrong. You have to write x equals 1 because that's the equation of that line. Write the equation in factored form. All right, so here's a little conversation. I'm going to cheat a little bit and I'm going to actually factor out the negative 1 right now. All right, and then that's going to give me this positive x squared, this negative 2x, and this negative 3 because I factored out my negative 1. And now I'm going to figure out what multiplies to give me negative 3 and adds to give me negative 2. So I'm going to play around with my 3 and my 1. And if I have a negative 3 and a positive 1, and bring this negative 1 out in front. Remember, by factoring out that negative 1, it prevented me from having a tricky trinomial. I didn't want a tricky trinomial. So by making this an x squared, it was your basic factoring. If I were to continue, I could set this equal to, again, to help me find my roots, it's going to be that x minus 3 would equal 0. Oops. Be forgiving of me here, guys. And x plus 1 is equal to 0. So I can already see that my roots are positive 3 and negative 1 from my factored form. Oh, there's your negative 1. There's your positive 3. I can also see that my roots are 3 and 1 because remember, it's where your y values are 0. There's your negative 1. There's your 3. and there's where it's 3, and there's my -1. So there's many different ways to find your roots. When I'm writing down my roots, I could just put it into set notation, -1, comma 3. Oops. Oh, see, that's what I'm not allowed to do. That was a good mistake for me to make so that I can correct it. Let's see if I can correct it easily. Oh, okay. So here we go. -1, 3. And here's my set notation because I cannot write parentheses. You could also just write x equals -1, comma 3. Remember, these are your solutions, your roots, your zeros, your x values. They have all those different names. Your turning point is your same word, turning point, and vertex is the same word. I can find it where I have the turning point. I can also find it because it is in the middle of my rainbow. So it is a coordinate, 1, comma 4. All right, my turning point, and is the vertex a minimum or a maximum? Since it's at the tippy top, it is a maximum. Great. So those are all the features you need to understand about how to graph a quadratic equation.